Hello, welcome back to this to the next chapter of my presentation about microservices architecture. Now, as we saw in the first chapter, we had an idea about what is microservice architecture and when and why we need to use them. So let's just deep dive a little bit into microservice architecture, how we can build it. There are many scenarios when we want to build a microservice architecture. The first scenario is to start from scratch. So you don't have a system, just a new startup, and we want to create a new solution. In this solution, maybe we choose the microservice architecture. This way is not the most common way used in the industry. The most common way used in the industry that you already have your system is already mature. And now we decide because for some reason, what we saw in the last chapter, that for some reason we need to migrate from the monolithic architecture to the microservices architecture. So there are different strategies, different pattern. We can find many books and many design pattern how we can move from monolith to a microservice architecture. But the most common to design pattern, the most common way to move from the monolith application to the new microservice architecture. And the first one is called the augmented monolith. So let's imagine that we have your application, you have your website platform or your e-commerce platform website, your e-shop. This is a monolith application, and we want to add a new capability to your system. Let's say we have to build new chatbots in your application. So in this journey to move from monolith to microservice architecture, maybe we have start this new capability with a new microservice architecture. So this will not be built within the monolith, but will be built using a microservice architecture. Sure that we need some bridge between the old or the legacy system and the new system the time we migrate on the whole system to the microservice architecture. When we finish it with the new capability, we maybe start by decomposing the monolith. You have just to have a map of your system. You have different uh, business capabilities into the system. You can regroup this business capability by domain and to start to move domain per domain. And in this time, we need to extract the existing capability from the system, from the base code and from the database, and to move it to a new microservice. In the same way as the first pattern augmented a monolith to augmented monolith, we needed just to create a bridge or the communication between the old system the time we migrate from the legacy system to the new system. So the idea here is don't start with the microservice. Why we don't have to start with the microservice? Because when you just have a new idea, we have to just a startup, the business requirement, the business capability are not mature enough. So the boundaries will not be well written between microservice or between different capability, and we can have some problem after that. So if you have just a new system, new brand new application, just start it with the good monolith. And after that, when the system become more mature and we can define the boundary between different business capability, we can move from our system from monolith application to a distributed or microservice application. Another way also that it's very important when we start thinking about microservices, it's to define the public interfaces. Why? Because it's the only way that can give us the ability to communicate with external component. Those external components can be external application, front-end application, or other microservice. And the interface is the contract between the microservices or between the others application. And it's also the way that's going to ensure us that even if we are making change within our boundary, we cannot and we deploy the new version of our microservices, we are not going to have an impact in others microservices. We are going to see that in the few camera slides, and we can deep dive in details in how we can manage the different version of our microservice or different version of the contract. So I have just to pinpoint or to focus again in the point that a microservice of their own database. Because as I say in many projects, when we start building the distributed part, sometimes we're going to merge two capability in the same database because we want to make some join between two tables that belong to these two different capability. And it's a huge mistakes because we only going back to the monolith architecture or to the distributed, I've called the distributed monolith. So be sure when you create your microservice, the database it will be within your boundary. It means it would never contain data from other domain. So this this database or the segregation of database can create some limitation. As this is sure, if the database joins instead of table joins. If you have to take some data from different database, we should have some aggregation, and there are many ways to make an aggregation in distributed system. But the point is to limit this aggregation because if we need a lot of aggregation between different domain or different databases, means that our boundaries are not well defined or well designed. It means we are creating the chatty communication between the microservices and the the design or the boundary is not on the border between microservices. We had a mistake. We made a mistake, and so we should to think about the boundary of our microservices. Another problem or another way challenge that we face in distributed systems is the transaction. We lose the transaction consistency. We become event-driven consistency instead of having one all our query will be executing the same transaction when we need to store the data in different parts of database. It's also another uh, impact or another consequences of not well designed border, not well designed boundary between microservices. So there are some way to mitigate the problem of database ownership limitation is to minimize the need to aggregate the data, and the only way to minimize that is to define very well your boundaries in your microservice. Caching can be also a solution when, for example, we need some data for only query purposes. Or let's have an example. You are in a catalog microservices and or in other microservice and you need information about the connected user. This information, we are not responsible to change this information, are just responsible to query this information. In this way, we can cache this data from the profile microservices within the other microservice. So that's going to improve the performance because we don't need to make a call within a network to get information about the connected user, and it improves the availability of the data. Imagine that the the profile microservice is down, even if it's down, so we still use all the information into cache, and we can improve our availability of the system. So even if this profile is down, you can make another in your application, for example. So we start by defining the seams in the database. It means the border between different capabilities within your data model. So when we have this kind of distributed architecture, we need to to accept the duplication of the data. So I know people who spend all his life using Murray's model or other models of duplicating data as denormalizing your model. So the denormalization of model can have a sense. Just take an example about catalog and order. Imagine that I have a product in my catalog. I have an ID, I have a name, I have a price. So when I choose to make an order, when I make an order of the product, I'm not going only to say, okay, I made an order of the product 1, 2, 3, 4, but I will also copy all the data, the name of the product and the price of the product. Why? It's very interesting to do that because the price maybe just can go up and go down. Maybe I can just change the name, but what is very important in the order side is the price and the name of the order, the time I make the I place the order. So even if this information is the same as about the order, but the meaning is, of this information is different. So I imagine that if the price go up, I'm within 2 or 3 days, I'm not going to impact the price when I made the order. It doesn't make sense if I choose to buy something with $3 or $4 and after that the price go up, so I'm going to change my price because that makes sense. Even if it's the same data, but the meaning of data is different, and the meaning of data depend of the domain or it depend of the boundary of the microservice. So here just a presentation using some code, people who love to see code. So microservice can consist on one or more than one process. It's a true. We see that because within the same boundary, within the same part of microservices is the most common way is to have your API, for example, and you have the database. But this API, we can have the scale out of your API. You can have many instances of the API. It makes sense that many instances of the API will use the same database. We're not going to create a database, for instance, because for the same business capability share the same database because they are just a replica set of my API, just a copy of my API. Another way to have multiple database or multiple workload when my database will be running is when I use NoSQL database, some or even for SQL database for sharding or replication. I have some fault tolerance on my SQL database and mirroring or always on or some configuration to allow the availability of my system. So we can have multiple parts or multiple points of entry of my microservice. I have my API that expose my business capability, but also can have myself, for example, schedule tasks. Let's have an example of the profile management. I have my API that expose the profile entry points. We create a profile if I need to check all the logic about the profile. But I have my scheduled task that is going to check the expiry date of the password. And if my password has been expired, it's going to send an email somewhere. So to do that, my microservices will not implement the technology to send an email. It will develop the logic to say I have to send an email, but the technology to send email will be developed in other services. But my microservice, when for example we detect that have some emails that have been expired, I will put them in the message processor and send a message to the microservice who is in charge of sending an email or sending an SMS or sending anything else. So the technology to send an email, it doesn't depend, or it doesn't, technology to send an email will be not be developed in the microservice, and the technology to send an email doesn't depend of the business. It's something that are very separated, but will be communicated between each other using my message processor. So the microservice should have a clearly defined public interface. We already talked about that. So the idea is when we want to change our contracts, we can maybe add a new endpoint or or change the contract, add a new property in my contract. So we introduce the version 2 of the API. So in this time, if we deliver a version 2 of we deploy a version 2 of our API, we should keep in mind that the version 1 clients must still be supported. Let's have an example. For example, I'm exposing my catalog uh, 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 capability. My catalog capacity has some attributes. Let's say uh, attributes about the product, something like a product type or product kind or something like that. My old consumer should continue to use my business capability, querying my catalog or creating new item in my catalog or changing information about my catalog. They should continue to use that even if I've changed my contract. So when I deploy the new version to have this characteristic of independency deployments, I don't have to force other consumer to change or to deploy or to adapt to the change. So I have to, in my side, to still support the version 1 of my API for some specific duration. And after that, maybe you can communicate with the client, okay, we have 1 week, 2 weeks, 3 weeks, or 6 months to update yourself to start using the version 2 of the API. There are many technique that can be used here. There are ones called the CDC, the consumer-driven contract. We can use some canary deployment to ensure that all my version of or my or client's version still communicate or still use my business capability. So microservice can be operated without their client needing to upgrade. And just this small scenarios that we have the team ownership of a microservice decide to make a change. They first add a new capability in the contract, then they deploy the updated microservice and later updates clients. Inform clients you have a new version and maybe within some several months or couple of months you have to update your contract to consume the API or to consume the microservice. So to ensure that this each feature will be deployed without impacting the client, so we need to create some unit tests or sort of automated tests to ensure that older version of the client are supported. So we can run that test as part of the CI build process to ensure all the version of the client are supported, what we call that the CDC. So be aware of shared code. We don't have to share code between clients or between the API because sharing code that can can break some tight coupling between microservice or between different components of the system. So to avoid all that, and I will repeat myself, but I just want to pinpoint this idea about the identification of the boundary. So getting them work wrong, it can bring the poor performance. Why? Because bringing having uh, or having any mistakes or wrong boundary between business capabilities, it will be translated by having chatty communication between different microservices. And when having microservices means the communication will be used the network. There is some latency in the networking. In this way, it will impact the performance of the application. And it will be also hard to change because our services are tightly coupled between them. So making any change in one microservice can impact another microservice, and we have the same problem as a monolith application. So the idea is very easy to start from existing system to identify loosely coupled components and to identify database seems to have your your boundary very well defined. So microservice should be organized about the business capabilities, and here we can just touch base in the domain-driven design. So after you identify abundant context, and within this abundant context means to break up a large domain. To have ubiquitous languages means that business line developers should talk or should speak the same language, and the developer should adapt to the business line language. So microservices do not share models. We saw that with an example order item and catalog item. Generally, we sketch your idea in a whiteboard. There are an event called the event storming. We bring all the problem and we try to find the boundary between the problem to identify the potential problems. So the pitfall of Microsoft boundary don't turn every noun into microservice. We create an anemic domain or anemic microservices, good microservice. Microservice is not about create, update, delete, and uh, and read. So your microservices should implement the logic, the business. If you have only the code, microservice means that the logic will be distributed elsewhere, will be developed by the front-end application. So uh, your Microservice or your domain should not expose the crude model. You should expose the business capability. We don't have create new products, but add a new products. It means that we handle all the logic about the products. We need to avoid circular dependencies. Something is very clear. We cannot create service one is going to call service two, a service two call service one, like that. And to avoid the chatty communication. So each of container service boundaries just a small example. We have a catalog boundary or catalog domain with the responsibility if the domain is the browsing for a product. It means we'll have large data sets, support flexible queries. It doesn't handle sensitive data. The basket is something is different from the catalog. It's preparing for purchase. It's short-living data. It's why, for example, we can use some memory database like Redis. Ordering the job of the order microservices process in order mostly write new data. We don't update an order, which is a kind of event event logging. We just create new products, and if we delete a product, we add a new line that means delete product. We have to track the history of the product. It can contain sensitive data like emails, address, maybe credit card or something like that. The identity microservice will handle only everything related to the authentication and the authorization. We have a marketing, for example, email marketing, and location is gonna handle all the capability related to the location of the users or clients. So, how will you break your application into microservice? There are some techniques as we go and see that in the next chapter. So, thank you for having me and see you later in the third chapter.